Okay, learning equations of lines. Okay, we can write the equation of a non-vertical line in several different ways. And you learned these ways last year in Algebra 1. So these are not new, just reminding you of these ways, okay? So these are non-vertical line equations, non-vertical, non-horizontal, okay? So the first one that we have in front of you on your page 17 is the y equals mx plus b. And I've written it really big on your notes right there, where m is the slope of the line and b is the y-intercept, okay? And they show it to you in two different ways over there at the equation here, and then they give you an example. So that example, we would know that your slope, oh, goodness, got it written really big there. There we go. For this example, you would know that your slope was 3 and that your y-intercept would be 8, okay? So if you were drawing this, you would go up 1, 2, 3, 4, 5, 6, 7, 8, put a point, and then your slope would be going up 1, 2, 3, and over 1, rise over run, and putting a point, and you would put a line through there. Do you remember how to do that, guys? I hope so. Okay. Now this one is called point slope form. The other one is slope intercept. Point slope is where we're given this equation, y minus y1 equals m times x minus x1, where the x1 and the y1 is any point on the line, m is still the slope, and we're able to then create the equation of the line. So this is when we're given a point and the slope, and we can create the equation of a line. Okay? The nice thing about it is, in this version, you can still find the slope. Okay? Now, if we're looking at the equation of horizontal and vertical lines, this one you need to know, and it kind of twists us around, okay? The equation of a horizontal line. So if we're looking at this, a horizontal line, the equation is going to be y equals b, where b is the y-intercept of the line, right here. Okay? And why this kind of twists us up is because it's parallel, I think, to the x-axis. And so something about us just kind of sits there and thinks, it's got to be an x equals, right? No. It's a y equals. And how I remember it, if I can't remember, if I'm doing this later and I can't remember, if I've got this horizontal line, so I'm going to highlight that again, and I can't remember how to do this equation of a line, I go ahead and I put a point there and I say, what's that point? That point is 1, negative 3. And then I find another point and I write down, what's that point? That one is 2, negative 3. And what's this point? Oh, that's 3, negative 3. And this point is 4, negative 3. Oh my goodness. And this point is 0, negative 3. What do all those points have in common? Every single one of them has y equaling negative 3. That's why the equation of the line is that y equals negative 3, because no matter what x is, y equals negative 3. No matter what x is, y equals negative 3. Okay. So I bet that makes it pretty easy to understand then why all vertical lines, the equation is then x equals the x-intercept. So this one would be x equals negative 2, because that's its intercept. All right. So why are we reviewing all this? Why are we going back to Algebra 1? It's because we can use these equations to understand by just looking at the equations if they're parallel, perpendicular, or neither. So we're going to look at these and determine that. So looking at this one, example 3, looking at A, are they parallel, perpendicular, or neither? So looking at the first one, A, in this one is in slope-intercept, right? Which is y equals mx plus b, right? Sometimes it helps us to put those right there in front of us. Y equals mx plus b, that's one of our options. Oh, I need my other one, there we go. Thanks. And my other one was y minus y1 equals m times x minus x1. There we go. Those are my two options. This one was slope-intercept. And this one was point slope. Okay. So in this one, that's slope-intercept. So where's my slope? It is right here. And this one, the second one, it's point slope, which means my slope is right here. I need a little thicker. There's my slope. So if I compare those, they are not parallel because they are not the same. Are they perpendicular? So if I look at that, 3 and negative 1/3. Now, at first, do they look perpendicular? Do they look like negative reciprocals? It's kind of confusing because this one is a whole number and this one's a fraction. But let me say this. Make them both fractions. So 3/1. Oh yeah, they are both negative reciprocals. Look at this. This is positive, that's negative. 3/1, 1/3. This one is perpendicular. Yep. And I could double check it by multiplying. It'd be negative 3/3, which is -1. That's that -1 product. Good. Okay, let's look at B. Y equals 3 and x equals 1. Y equals 3 is horizontal and x equals 1 is vertical. That means they are perpendicular. All right, next one. Ooh, got another point slope there with a slope right there and a y equals mx plus b. There's our slope. They are the same, so they are parallel. Here's my slope. Here's my slope. 2 and 1/2. Okay, let's make them both into fractions. They are reciprocals, but they are both positive. So they are neither parallel nor perpendicular. Okay. And then these are both x equals -2 and x equals 4, which means they are both vertical lines, which means they are parallel because all vertical lines are parallel to each other. There we go. And those are going through all those. Now you go on to the practice. You go try those and pause me. Right? Did you get that they were perpendicular, parallel, and parallel? All right, let's try another one. Valentina is designing a park using grid paper. She wants to build a sidewalk that connects with the fountain at P 0 and 1, and is perpendicular to the existing sidewalk that passes through points -6, -2, and 0, -6. Graph the line that represents the new sidewalk. All right. So this is a little bit interesting. I like this one. Okay. So what we're going to do, I'm going to go off to the side here, and I am going to, can I insert? Add a page. There we go. Cool. Get rid of that. Okay, so if she wants to build a sidewalk that connects with the fountain at a point, so she wants it to go through this point up here, and it goes perpendicular, so she wants it to go through like that at a 90 degree. So she needs to know the slope of this line, and then she needs to make a line, or graph a line for that one. Okay, so let's find the slope. So slope is m equals y2 minus y1 over x2 minus x1. And we've got our points up here, x1, y1, x2, y2. We'll go 0 minus a -6 over -6 minus a -2. Those become positive, those become positive. We get 6 over -4, which is, we can simplify that. They both divide by 2, so we get 3 over 2, and it's a negative. So it's -3 over 2. Okay, so we're going to come up here, -3 over 2. So if we just need to graph the line, that means we can go over here, and it means that we go, rise over run means we go down 3 over 2. That's what this is doing. It's going down 3, 1, 2, 3 over 2. Does that look like that's what that line's doing? Rise 1, 2, 3, 1, 2. I think I might have done mine wrong. Let's go look at it again. Oh, 6. I put it in the wrong spot, didn't I? Mrs. Cruz. Wrong spot. I'm sure you guys were yelling at me, weren't you? -6 minus a -2 over 0 minus a -6. Thanks for yelling really loud. I appreciate it. -4 over 6. There we go. -2/3. That looks better. Down 2 over 3. Yep, down 2 over 3. -2 over 3. Perfect. Okay, so we found our slope. The slope is -2 over 3. So if I want the perpendicular slope, it's a negative reciprocal. So I'm going to change the sign and flip them. +3 over 2. +3 over 2. Okay. So now I'm going to come up here to this point up there. And what I'm going to do is I'm going to go up 3, 1, 2, 3, and over 2, and put in a new point. That's going to be where my line goes through. I might go up 3 and over 2 more. There we go. And I'm going to draw my line through all those points. Down we go. And there we go. And that will be perpendicular to that sidewalk. Now I want to go one step further. I'm going to create the equation that is perpendicular. And goes through. Zero, 1. Because I know you're going to have to do that in ALEKS. Okay? So first, you find the slope, which was negative 2/3. Then make it perpendicular, which is 3/2, which we did. And then we're going to use point slope, which is that y minus y1 equals m times x minus x1. So we can use this to find the equation of that line we just drew up there, okay? So that's what we're going to do. We're going to say y minus, and we have these points. They're up here. That's the point we're going to go through. And we have the slope. Oh, that's not what I wanted to do. We have the slope. This is the new slope for it. So y minus 0. Nope, that's not my y. Make sure I don't screw it up. Over 3/2, that's my new slope, x minus 0. Okay. And then turn it into slope-intercept form. Okay? And that's what ALEKS is also going to have you do. So I'm going to copy that and I'm going to paste it down here. And here's what we're going to do. We're going to distribute. So you get y minus 1 equals 3/2 x, because 3/2 times 0 is 0. And then we're going to add that 1 over. And we get y equals 3/2 x plus 1. And that is the equation of this line up here. Y equals 3/2 x plus 1. And look at that. There's our y-intercept of 1, and it goes up 3 and over 2. That's our slope. Okay. That was a little more than you bargained for in that. I get it. You can screenshot that if you want. That'll help you with ALEKS. All right. And you can go ahead and, go ahead and practice that one. Pause me. All right. And did you get this equation? All right. Last little bit. Write an equation in slope-intercept form for the line parallel to y equals negative 3/4 x plus 3 that contains negative 3, 6. Okay. This is similar to that one that we just did. I'm going to add a little bit extra paper just in case I run out of space. There we go. Okay. So again, we're going to use that point slope where it's y minus y1 equals m times x minus x1, because we've been given a point. We've been given this point, which can go in here and here. All we need is a slope. They tell us it's parallel, which means we need the same slope, so we just need to go pick that slope out. So our m is negative 3/4. Here's our x1, and here's our y1. So let's go plug it in. Y minus 6 equals negative 3/4 times x minus negative 3. And I right away turn that into a positive just so I don't mess myself up. All right? Then I'm going to distribute. I get y minus 6 equals negative 3/4 x. And negative 3/4 times 3. And if you're trying to figure that one out, just turn it right into a fraction right away. 3/1. So what's that? Negative 3 times 3 is 9/4. Okay, so let's see. Y minus 6 equals negative 3/4 x minus 9/4. Okay. Or we could say that that is also minus 2.25. That would be okay as well, because that does come out to a nice little decimal. All right, and then we're going to add 6, and y equals negative 3/4 x. And we're adding 6. So if we add 6, goodness. If we add 6, and we're doing fractions, add 6, we have to take it times 4, it'd be 24/4. There we go. There we go. So, plus 15/4. That's what it ends up being. Get my black out here, though. Plus 15/4. There we go. Let's see if I did all my math right. Okay. Plus 15/4. Woohoo! Okay. You will have to probably deal with fractions because those slopes are in fractions. All right, let's see how you do now. Go ahead and try practice 5. Pause me, take a shot. Did you come up with y equals 1/2 x plus 1/4?